This video will give a short introduction to the language used to define applications in Persistate. I have very tentatively dubbed this the Persistate Definition Language, PDL or PEDL. There are two significant aspects to PEDL. Firstly, it works purely in the business domain and allows you to define your application in business terms. Secondly, a PEDL definition acts as a single source for generating a three-tier application, following the industry standard Model View Controller application architecture. In the model domain, PEDL can be seen as a managed way of defining data structures. Very roughly speaking, you could say that PEDL is to SQL, as Java or C# is to C. PEDL has class definitions containing members, and there are relationships between the classes, but there is no low-level apparatus such as primary or foreign keys or linked tables. To give an example of the difference, in SQL, if you have a table of publications with an ISBN field, you will have to create a unique index on this field if you want to ensure uniqueness or look up ISBN numbers. In PEDL, you simply qualify the ISBN member as distinctive. Furthermore, the distinctive qualification provides functionality in all parts of the application, not just the model. Showing here is the PEDL definition for a sample library application. The first thing that you can see from this is that the language has been designed to read as correct English. The vocabulary used has been carefully chosen to be as meaningful as possible to non-specialists. So, for example, the term diverse in PEDL means pretty much the same as it does in English. In this definition, there are various types of statement. The first line is a comment. Next, we have a use statement used to import another package. After that is a set of data class definitions, each of which describes a single item. The bulk of the file contains object class definitions, each made up of a list of members. Near the end, we have two view class definitions, which define queries spanning several classes, and finally, a workspace definition, which describes an arrangement of panes for the user interface. Let's look at the data class definitions. These define the type of a single item. There's not a one-to-one correspondence with .NET value types here. Some data classes are held in objects, such as strings, fonts, and images. There are 10 classes defined here. The first 6 define textual items. For these, you can optionally define a typical and maximum length. The typical length is used by Persistate to determine the width of input boxes in generated user interfaces. If you supply a length, you can omit the base type, and Persistate will assume text, as has been done with the name class here. Next, there are two numerical items, copy number and borrowing limit. The first can take any integer value, and the second any value between the two stated bounds. In the latter case, you can again omit the base type, and Persistate will infer it from the bounds. The length status class here is a multi-value type. The values are textual and can contain spaces. Persistate will portray such classes in a user interface as list boxes, combo boxes, or radio buttons. As well as having mutually exclusive values as shown here, you can also specify combinable values. The last data class here specifies a date-time base type. There are a number of other base types available, such as floating point, currency, binary, and image. The Persistate website documentation has full details. Most of a typical PEDL definition will be taken up with object classes. These start with either the or each. Taken as a whole, the object classes define a containment hierarchy. This is, for each Persistate application, one or more trees of persistent objects. An object class beginning with the, such as the library here, defines a singleton, which is a root object of a tree. You can have more than one singleton, so you can define more than one tree in one PEDL application definition. However, all your defined singletons are actually contained in another object, and the containment hierarchy you define is in fact part of a single tree of persistent objects which makes up your Persistate domain and encompasses all your Persistate applications. At the start of an object class definition, you give it a name, such as book, genre, or lend, and optionally a containing class. Here we see that genres are contained in the library. You can also specify a class category, such as stable or transitory. Most classes here are stable, which means that instances are not linked to a point in time and do not change frequently. We can see that the len class is transitory. This means that the instances tend to be linked to a point in time and tend to accumulate. Persistate uses the category to tailor how objects are treated by the Persistate infrastructure. Finally, you specify a base class. This will often be the class persistent, which is the root of the Persistate class hierarchy. But here, for example, we can see that book is based on publication. Persistate supports a full class hierarchy. Object classes have a list of members, conventionally listed one per line. Members can be properties or operation groups. Properties can be a single item, such as the library name here, or a collection such as authors, publications, borrowers, and so on. All properties must have a name and a class. The class can be an object class or a data class. For collections, you use the English plural for the class name. The property name can be just a class name, such as authors and publications in the library, or it can be just a given name, such as forename and surname in the person class, or it can be a combination of the two, such as the full name in the person class. In this latter case, an underscore is appended to the given name to indicate that the given and class name make up the property name. Here is the generated library application running, showing an author form. You can see the correspondence between the properties of the author class and its base class person, and the generated elements of the user interface. Note how the English property names have been used for the element captions. Persistate has three types of collection. Collections of several objects, such as the library's collection of genres or an author's collection of books, are always available in their entirety when in memory. Collections of many objects, on the other hand, are always handled a subset at a time. Persistate generates methods to retrieve subsets based on the nominative, distinctive, or discriminative members of the collection class. So, for example, the library will have a generated method called authors with surname to access its collection of authors, since the author class has an inherited surname member which is marked as nominative. There are also collections of selected objects, such as the library's monthly len statistics collection. These are collections of view class objects created by a query involving one or more object classes. For more on view classes, see the Persistate website. In the generated application, a collection of several objects is shown typically in a simple grid, like the library collection of genres here. However, if you look at the library's collection of many borrowers, you get a lookup form. This form is generated by Persistate for classes which feature in collections of many objects. It contains lookup elements for nominative and discriminative properties of the borrower class and its base class person. So we get forename and surname from person, and from borrower we get postal address. But that's an object class, so Persistate takes the appropriate members from that, which are street and city. If we show the library publications, then we get a lookup form with a class selector at the top. This is because this collection is marked as diverse, which means that it can contain publication objects or objects of any class derived from publication. Publication has two derived classes, book and periodical. So we can choose to look up any publication or a periodical or a book. As well as properties, object class members can be operation groups. Here, the library has an operation group called action. This contains 4 operation definitions. Persistate will generate stub methods corresponding to each defined operation, ready for you to code your business logic. It would also generate elements in user interfaces which trigger execution of these methods. Typically, an operation group will correspond to a menu and the operations to items on that menu. You can also nest one operation group within another. In this case, the nested group will correspond to a submenu. In the generated library application, you can see the 4 defined operations on the action menu. If we select one, we get a not implemented message, as the implementing method is still just the generated stub. We have seen that the set of object classes in the PEDAL definition defines a containment hierarchy, a persistent tree. So, for example, the library contains several genres and many diverse publications, and each publication contains several stock copies. Each object has a parent property, which gets the object that contains it. So the parent of a stock copy is a publication, and this is reflected here in the definition of stock copy. Persistate also allows you to have members in an object class which are not contained in that class. These are known as associated members. For example, a book, which is a type of publication, has an associated genre. But the book is not the parent of the genre. Genres are contained in the library. Similarly, a book has an associated author. Authors too are contained in the library. An object has only one parent. In other words, it is a contained member of only one object. However, an object can be an associated member of any number of objects. So a genre or an author has only one parent, the library, but can be an associated member of any number of books. You can have associated collection members too. For example, borrowers have several associated lent stock copies. But the borrower does not contain the stock copies. They are contained in a publication object. Different elements in an associated collection can be contained in different parent objects, and any one object can be in any number of associated collections. Associated collections implement a many-to-many relationship. Associated members can be given a from clause. If included, this indicates the source collection for the object or objects to be associated. In the book class, the associated author should come from the library authors, and the associated genre should come from the library genres. We can see how Persistate uses this if we create a book in the generated application. I'll put up the publication lookup form and click New. Since the publication collection is diverse, we get to choose what type we want to create, a publication or any of its derived classes. I'll choose Book. This is the book form, automatically generated by Persistate. For the genre, we get a combo box, since the collection indicated by the from clause is a collection of several genres. For the author, on the other hand, we get what's called a nominative and lookup box, since in this case, the collection indicated by the from clause is a collection of many authors. If I click the button, I can use the author lookup form, which is again automatically generated, to choose the author I want. Note the text in the box. This uses the author's nominative text property, which Persistate generates to return the concatenated values of all nominative members of the author class, in this case, the forename and surname members inherited from person. That completes this introduction to the Persistate definition language PEDAL. There is quite a bit I haven't mentioned, such as class category definitions, view classes, within clauses, and workspaces. The Writing Definition Files section of the Persistate website contains full documentation for the PEDAL language.